All right, in class, some of you, we kind of did a problem-solving approach to this, and we'll look at this with Algebra 2, but from a problem-solving approach, a lot of you were like, why can't we just multiply this by 15% and subtract? And so remember, if you're going to work backwards in a problem-solving approach, you have to undo the math and use inverses, which is fine. But again, think if you have a $100 meal, and you're going to do a 15% tip. Okay, and again, 10% would be $10, half would be 5, which is 15, or just the definition of 15%, right, is 15 out of 100. So for every 100, you'd have a $15 tip. Regardless, 115 bucks. Okay, but I mean, yeah, you're taking 15% and you can add it, but in reality, the math that you're really doing is you're taking 115% times that 100. You're just choosing to do it in 2 steps by doing the 15% and then adding, but in reality, it's 115%. All right, so when you go backwards, you would have to do the reverse of that. If forwards would be multiplying, then the reverse would be dividing. So if you take this divided by that, it will get you backwards because you're undoing the original math. Now, some of you in class wondered, well, you know, why can't I take, say, this times 15% and subtract? Well, there's a couple reasons why. First of all, one of them is the thing that you originally multiplied by 15% is this. So here you're changing that. You're not undoing it. You're using new numbers and almost finding a new tip for that amount. All right. And so if I take 115 times 0.15, that's 17.25. So that would be the tip on this price meal, but it certainly wouldn't be the price of the tip on that guy. So if you subtract, all right, so if you take this number and you subtract that, okay, notice you're using numbers that were really never part of the original problem. Just the 15% was, but the numbers that you're using that you calculated were not, you're not doing those backwards. And so that's 97.75, which again, you can see is not your $100, okay? So if in reality, when you move forward, you're multiplying by this, to move backwards or to undo the math, you would have to divide by that. So let's look at the problem I gave you here. You have the price of the meal plus the tip on the meal, and that equals $28. All right. So here's 1. So you have 1 and 0.15, and you get that. So again, in reality, when you do this problem, if you have a tip, you're really multiplying by 115%. That's the result of combining this with this, is in reality, this is the math you're really doing. So if you know the answer and you want to go backwards, you have to undo that multiplication. And so to undo multiplication, you would divide. All right, and so the meal is 28 divided by, what is that, 1.15, which is approximately $24.35. Okay, now if you want to check your answer, you can multiply this by 0.15 because that is what happened originally. Like in the original problem, yes, someone could have multiplied that by 1.5 and add, so the tip is approximately, let's see, what, 365, and you do really get $28. Sorry about that, my battery is going to die here. Okay, and the same would be true if you had a discount problem. If you had a coat and you had a 25% discount on it, and say afterwards it's $40, in reality, this is really that you're paying 75% of the cost. You can't multiply this guy by, say, 25% and try to, you know, go backwards and add it back in, because in reality, the math that's happening is it's multiplication. You are paying 75% because percents deal with multiplication. That is the core of percents, right? And so to undo multiplication or to work backwards, you would have to divide by that 75%. And so if I took 40 divided by 0.75, I would end up getting $53.33. All right, I hope this explains why you can't just do the 15% or the 25% times the result, that you have to go back and divide to undo the multiplication. If not, I can make another video and try to clarify that.